Okay, the last agent of weathering and sculptor of the Earth we're going to talk about is ice. Ice in the form of glaciers. Glaciers are probably my favorite agent of erosion. They create spectacular landforms, and we're going to see a lot of glacial landforms on the trip in Colorado. Okay, there's two main types of glaciers. The first is Alpine glaciers, and these are the ones that we're going to see the past evidence of in Colorado. Alpine glaciers form in mountains, and they flow in mountain valleys. So they're confined in the mountain valleys here. So here's a glacier flowing down this valley from this ridge all the way down this way. We can see some of the debris that falls on top of it that comes down off the mountains. And it's basically a river of ice. We get a lot of snowfall up here, it gets compacted into ice, and then it flows down valley under its own weight. The other main type of glaciers are ice sheets, sometimes called continental glaciers, and these are unconfined. The ice forms and it flows over a huge landscape, and it generally smooths things out. We've got two ice sheets currently on Earth, one in Greenland and one on Antarctica. And so again, these are unconfined glaciers, or they're sometimes called ice caps, and they flow over a whole land surface, smoothing it out. In the past, we had more extensive glaciers, so basically climate has warmed and cooled over long periods of time. Sometimes that warming and cooling has been pretty dramatic, and so this is about 18,000 years ago. We can see we had this ice sheet that went all the way down into the northern parts of the United States and all over Canada in North America, and this ice sheet then climate warmed, starting about 18,000 years ago, and this ice sheet started to recede and melt back, where now we only have an ice sheet on Greenland up here. Okay, the way glaciers form is you have to have a region where snowfall exceeds snow melt. Right, so more snow has to fall in the winter than melts in the summer. So basically, some snow falls in the winter, some of it melts in the summer, and then more snow falls on top of it the next winter, and on and on and on. And so the snow gets compacted into glacial ice. Places where snowfall exceeds snow melt are typically found at high elevations. This is where your alpine glaciers form, or at high latitudes, so near Antarctica and Greenland. So places where it's very cold, we have more snowfall and less snow melt. And this is kind of how it happens. So we have regular snowfall. If you've been out in the snow, you know it's pretty powdery stuff. Most of that is air. So snow is about 90% air when it's fresh. Over time, as that snow compacts under its own weight, and then we have some partial melting, so our ice crystals, snowflakes look like this. We have some partial melting as they're compacted, and they start to look like this, and now we're down to about 50% air, and that's kind of granular ice. If we melt them a little more and compact them a little more, we get this thing called firn, which are more like little globs than they are like ice crystals, and that's about 20 to 30% air. And then finally, when we're down to about 20% air bubbles, you can see the little air bubbles in here. That's glacial ice, and so there is a lot of air in there, but it's basically solid ice as we would think of it. Okay, glaciers flow under their own weight. So we talk about running water, you need a gradient, right? To have a stream, you have to have some kind of slope for that water to flow. But glaciers, because we have a zone of accumulation, the glacier is going to flow, its own weight is going to push it outwards or downwards. So I like to think of especially a continental glacier as a pancake on a griddle. I really like pancakes, probably my favorite breakfast food. So if I pour the batter onto the griddle right here in the middle, that's our zone of accumulation. This is where our snowfall exceeds snow melt, where we have a lot of snow in glacial ice forming. And then it's going to ooze out, and this is on a flat surface, a continental glacier, so this is going to flow out in all directions like this. And it really is just the weight of that batter pushing pushing it forward along the griddle. It doesn't have any slope to flow. And glaciers can be delicious. All right, now glaciers do a lot of eroding, right? They scour the landscape and really carve really interesting features. But it's not the ice that does it, right? You could take an ice cube and you could take a rock and you could rub them together, and you're not going to rub any rock off with that ice cube, right? Rock is harder than ice. So it's not the ice that does the scouring. But as glaciers flow, they pick up stuff. They pick up sediment. They pick up sand and silt and clay and rocks and boulders and everything else. And those things kind of form this sort of flowing sandpaper. And that's what carves grooves into the rocks, right? And that's what scours the landscape. So any place that has that's been glaciated, you can find these little grooves in the rock that are all parallel, moving in the direction of glacial flow. Those grooves are called striations, and they've been eroded by the sediment being carried by the glacier. Okay, so let's look at some alpine glacial landscapes. This is the stuff we're going to see in Colorado, and it's really just some of the most beautiful scenery that we're going to see on the trip. So we start out here with some unglaciated terrain, right? We have a mountain here, and we've got stream valleys in it. So in these stream valleys, you know, these are V-shaped, narrow valleys, right, with little headwater streams in them. And, you know, we have a main stream flowing down here, and we have tributary streams that come in, so we have these series of valleys and ridges. Those ridges are pretty rounded on top, and those stream valleys are very narrow and V-shaped. Then if we have climate cools, right, and so now we start getting snowfall in those mountains that exceeds snow melt, and so the snow keeps building up deeper and deeper and gets compressed under its weight into ice, into glacial ice. And so now we see that those valleys have now filled with ice, with glaciers. They're still flowing, and the ice follows the paths of where the old streams were. So we have the tributary glaciers and the main glacier flowing in there. And the main thing that glaciers do is, instead of V-shaped valleys, now we have these broad U-shaped valleys. And that's because glaciers have such incredible capacity to erode. Then let's say climate warms again and those glaciers melt. What we're left with is this really incredible carved scenery, right? So now we have this big broad U-shaped valley called a glacial trough. We have U-shaped tributary valleys up in here that flow in. Those valleys don't go all the way down to the bottom of the glacier. They only came to the top of the main glacier, so they're actually hanging valleys. And then now our ridges are very sharp knife edge ridges rather than rounded ridges. Okay, so anyway, here's just another illustration of the same concept. So here we have a narrow V-shaped stream valley. So our main stream goes down this way, and we have some tributaries coming in through here. And now it's glaciated. So we have our main glacier has carved that narrow V-shaped valley into a big, broad U-shaped valley, or a glacial trough. We have our tributaries coming down here. Now, when glaciers form, they carve at the heads of their valley. They carve these big, broad, bowl-shaped depressions, and that's because that ice is plucking out and scouring the headward part of those valleys. Those are called cirques because they're big, bowl-shaped depressions. And then, because the glaciers carve on two sides of a ridge, they carve those ridges and make them very narrow. So we have this very narrow knife edge ridge here, and that's called an arête. If you have glaciers on at least 3 points of a high point, so here we have a high point, this little peak, and then we have cirques. We have glaciers on 3 sides, right, coming off of it. And so what that does is it leaves this very sharp point at the top, and that's called a horn. Now, glaciers move a lot of sediment. So here our main glacier is coming down the valley, right? And it's scraping along the valley walls here, and a lot of sediment is generated. And that sediment falls down on top of the glacier, creating these stripes. And those are called moraines. So a moraine in the middle of a glacier like this is called a medial moraine. And a moraine on the edge of a glacier over here is called a lateral moraine. So then those, if climate warms again and those glaciers melt off, we're left with a big broad valley that now just has a little stream running down it. Now remember, our tributary glaciers can't erode all the way down to the bottom of a glacier because it can only reach, once it reaches the top of the glacier, it's at base level. So we now have this cliff, right? We have what's called a hanging valley, and you often get waterfalls there. They're very beautiful. As those glaciers break up and melt and retreat, they often create little depressions, right? A block of ice will break off the glacier as it's retreating. It'll create this little depression, and sediment will fill in around it, and that creates a little glacial lake. An individual glacial lake is called a tarn. But sometimes we have strings of these. So we have strings of tarns connected by a stream in that U-shaped glacial valley. The string of lakes are called paternoster lakes. Paternoster is Latin for our Father, and that's because some people think these look like a string of rosary beads, right? Because you have the lakes here connected by the string of the stream, so paternoster lakes. And then we have the same landforms here. We have those knife edge ridges, those arêtes. Here's our horn up here, and our cirques, our big bowl-shaped depressions. Here's just some photos of some of these things. So here's a glacial trough in Norway. The giveaway here is you've got a big, broad U-shaped valley. We're going to see some of these in Colorado. Here's maybe the most famous horn in the world, the Matterhorn in the Swiss Alps. So we have a glacier coming off this way, a glacier coming off this way, a glacier coming off the backside. So it leaves this high, sharp point in between them. Here's an arête, so a sharp knife edge ridge. We have a glacier flowing down this valley. We have another glacier on the back side, leaving this sharp ridge between them. Here's a cirque, so this is the very head of a glacier. It carves out this big bowl-shaped depression, and the glacier flows down this way. And then here's a hanging valley. So somewhere down here we would have had our main glacier. The top of that main glacier would have been right there. And then we had a tributary glacier coming in an old stream valley. And so that creates a hanging valley. And if there's a stream in this hanging valley, we have a waterfall down to the bottom of the main valley. Okay, and then here's a nice view of moraines. So here we have a glacier coming out from around this way and flowing down here. And we have another glacier flowing out of this valley, flowing down this way. So as this glacier, let's say A right here, as it's scouring along the side of the mountain here, all of these rocks and debris are falling down on top of it, creating this moraine. So this is a lateral moraine because it's on the side of this glacier. Now this glacier over here, B, also has a lateral moraine. It's scouring along here. But as these two flow together, they come together at this point here, and now this is a medial moraine because it's in the middle of this new big broad glacier. So the region of Colorado, where we have a lot of high mountains that were glaciated about 18,000 years ago, here in the southern Rocky Mountains. So in the middle of the state where we have all these high mountains that have been folded and faulted, we had a lot of glaciation too. So we'll keep our eyes open. We're going to spend a lot of time actually right over here in the Elk Mountains, where we have some beautiful glaciated peaks. So we'll see all of those landforms there.